Good morning, dear my students. I am glad to see you. Welcome to this my lecture 2, Introduction to Computer System, Architecture of System Computers. Lecture plan, Introduction to Computer System, Architecture of Computer Systems, Motherboard, Processor, Internet, Internal Memory, RAM and ROM, Video card, aka graphics card, sound card, storage devices. The computer system has a modular structure for each device, memory, peripherals. In the system, there is a special control device. In other words, a special processor called a device controller and L modules, SPU memory controller, peripheral device, and their controllers are interconnected by the system bus through which they exchange signals. As we already know, the controllers controls the operation of each driver specialist low-level program, which is a part of the OS. The central processing unit, a device that executes commands, instruction of the computer system. In modern computer, as a rule, it is a multi-core, that is composed of from 2 to 30 cores, copies of the processor operating in parallel on a shared memory or hybrid consisting of the central and SPU. Performance per core from 3 to 32 gigahertz. Note that under the performance is understood in this case the clock frequency of the processor core during the performance of a very simple machine instruction. However, there are other important factors that determine overall system performance. Clock rate of memory and system bus. In fact, the final performance of the system can be estimated by the slowest of this part of the system, usually the system bus. These characteristics should be taken into account when choosing and buying a computer. Computer system, system unit, output devices, output devices, input devices, input devices, output device, a computer system. Components of the system unit. Motherboard. The motherboard is central to any computer system. All components plug into the motherboard either directly straight into the circuit board or indirectly via USB ports. Once connected to the motherboard, the components can work together to form the computer system. Components communicate and send signals to each other via the bus network. Motherboard. Motherboard, CPU slot, RAM memory slot, connection to power supply, slot form slot for hand disk drivers and DVD-ROMs. Uh, PCI slot PCI slot can connected sound cards, graphics cards, etc. Uh, graphics card slot, graphic card slots. A back panel with connection for peripheral and USB form, USB memory. Motherboard has a bus network. This is a collection of wires which allow components to communicate. Processor, SPU, Central Processing Unit. The Central Processing Unit is the brain of the computer. The SPU controls what the computer does and is responsible for performing calculation and data processing. It also handles the movement of data to, to and from system memory. SPUs come in a variety of speeds which are known as clock rates. Clock rates are measured in hertz. Generally, the faster the clock rate, the faster the performance of the computer. There are two main brands of SPU currently on the market, AMD and Intel. Processor SPU Central Processing Unit. Intel SPU, Intel SPU, AMD, AMD SPU, connecting pings. The difference between Intel and AMD SPUs is like comparing Coca-Cola and Pepsi. It is a matter of preference. Intel SPUs do perform better at certain tasks, but they cost more to buy than AMD SPUs. Physically, they are slightly different, which with Intel SPUs tending to have more pings. RAM main memory or a memory a device that stores the processed data. Memory capacity from 4 to 32 gigabytes or more. Less memory use is not recommended as this may lead to significant slowdown of the system. Memory clock speed 6, 600, 667 megahertz to 115 gigahertz. gigahertz. The system bus, a device which is connected to the computer and all the modules through which they exchange signals. The clock frequency of the bus from 1 to 1.5 gigahertz. This is actually a kind of overall system performance. PCI bus type usually used peripheral components in interconnect. To it can be connected SPU memory disks, printer, modem, and other peripheral devices. Internal memory, RAM and ROM. There are two types of internal memory, RAM and ROM. RAM and ROM are used to store computer data, and this can be directly accessed by the SPU. RAM and ROM are sometimes referred to as primary storage. RAM, random access memory. RAM is used to temporarily store information that is currently in use by the computer. This can include anything from Word documents to videos. RAM they can be read from and written to, and so the information stored in RAM can change all the time. It depends It depends what tasks you are using the computer for. RAM is a fast memory data can be written to and read from RAM very quickly. RAM is generally measured in gigabytes. RAM is volatile memory. This means that information storage in RAM is deleted as soon as the computer is turned off. Memory. Storage is usually too large to be expressed by in bytes or words. Words. I- Instead, we used kilobyte equal 1024 bytes to the 10 10 power of bytes. Megabytes equal 1024 by 1024 bytes or 1 million bytes to the 20 powers bytes. Gigabyte equal 1024 by 1024 by 1024 bytes or 1 trillion bytes to the 30 30 power of bytes. Terabyte equal 1024 by 1024 by 1024 by 1024 bytes on quadrillion bytes to the 30 30 power of bytes. ROM, read-only memory. ROM is used to permanently store instructions that tell the computer how to boot stand up. It also loads the operating system. These instructions are known as the BIOS, Basic Input Output System, or the boot program. Information stored in ROM is known as read-only. This means that the contents of a ROM cannot be altered, altered or added to by the user. ROM is fast memory. Data stored in ROM can be used, accessed, and read very quickly. ROM is non-volatile memory. This means that stored information is not lost when the computer loses power. Other examples of ROM include DVD, CD-ROMs, both storage containing pre-recorded music and movie file. These are played back at home but cannot be altered. ROM in printers, which is used to store different font types. Video card, aka graphics card. Graphics card, a hardware device that plug into the mother, motherboard and enable the computer to display images on the monitor. Graphic cards usually require the installation of software alongside the hardware. The software instructs the computer how to the graphic card and also allows you to alter settings to change image quality and size. Sound card. Sound cards the internal hardware devices that plug into the motherboard. Sound card's main function is to allow the computer system to produce sound, but they also allow user to connect a microphone in order to input sounds into the computer. Sound card are also useful in the conversion of analog data into digital and vice versa. Storage device, secondary backing storage. Secondary storage devices are used to store data that is not instantly needed by the computer. Secondary storage devices permanently store data and programs for as long as we need. These devices are also used to back up data in case original copies are look of demanded. Remember, uh, temporary storage like RAM does not hold data for long periods. It is used to storage only choose program and file that we are currently working on. There are two categories of storage devices: internal storage, internal hard disk drivers, internal storage, internal hard disk drive, memory stick, etc. Access to instruction: hard disk, main memory, CPU, I/O, diagram a computer. The hard disk is too slow to provide instructions to the CPU, so programs are first loaded into main memory, which is much faster. The CPU can then access the instruction more quickly. Cache cache memory. But as CPU speeds became faster, the main memory couldn't provide the CPU with the instructions at a fast enough rate. So even faster memory, cache memory, is now placed between the CPU and main memory to provide the instruction at a quicker rate to the CPU. Cache memory, second secondary storage, main memory, cache memory, CPU, I/O. Diagram a computer with cache. When an instruction or data is accessed from main memory, it is placed in the cache. Second and subsequent use of the same instruction, data will then be faster since it is accessed directly from the cache. A, a last of a reference to Explorer. Thanks for your attention.